Welcome. Today we're going to explore linear regression, one of the most fundamental and widely used algorithms in machine learning and data science. In the next 15 minutes, you'll understand exactly what linear regression is, how it works, and why it's so important. Let's dive in. Linear regression is essentially about finding the best straight line through your data points. Imagine you have data showing the relationship between house size and price. Linear regression finds the line that best predicts price based on size. The goal is simple. Given some input, predict a numerical output. It's called linear because we're fitting a straight line, and regression because we're predicting continuous values, not categories. Linear regression is everywhere in the real world. Netflix uses it for recommendation scoring. Banks use it for credit risk assessment. Retailers use it for sales forecasting. Healthcare uses it for drug dosage calculations. Weather services use it for temperature prediction. Stock markets use it for price analysis. Anytime you need to predict a number based on other numbers, linear regression might be your answer. The equation is surprisingly simple. Remember y equals mx plus b from school? That's linear regression. Y equals beta 0 plus beta 1x, where y is what we want to predict, house price, x is what we know, house size. Beta 0 is the y-intercept, the base price. Beta 1 is the slope, or price per square foot. For multiple features, we just add more terms. Y equals beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3, and so on. That's it. The algorithm's job is to find the best values for these beta parameters. But how does the algorithm find the best line? It uses a process called optimization. Start with a random line, any line will do, measure the errors, how far off are our predictions, adjust the line, move it to reduce errors, repeat until we can't improve anymore. The algorithm minimizes the mean squared error. Basically, it tries to make predictions as close to reality as possible. This process is called gradient descent, and it's like rolling a ball down a hill to find the bottom. Here's what linear regression looks like in Python with scikit-learn. That's it. 5 lines of code to build a house price predictor. The beauty of linear regression is its simplicity. Why is linear regression so popular? It has several key strengths. Interpretability. You can easily understand what each feature contributes. Speed. It's incredibly fast to train and make predictions. No tuning required. Works well with default settings. Baseline model. Great starting point for any regression problem. Probabilistic. Gives you confidence intervals, not just predictions. Well understood. Decades of research and proven techniques. It's like the Swiss Army knife of machine learning. Simple, reliable, and gets the job done. But linear regression isn't perfect. Here's when it struggles. Non-linear relationships. If your data curves, a straight line won't fit well. Outliers. Extreme values can throw off the entire line. Too many features. With hundreds of features, it can overfit. Categorical predictions. It's only for predicting numbers, not categories. Red flags to watch for. Your scatter plot looks curved or clustered. You have more features than data points. You need to classify things like spam or not spam, cat or dog. Extreme values dominate your dataset. There are several flavors of linear regression. Simple linear regression. One feature predicts one outcome. Example, predicts salary from years of experience. Multiple linear regression. Multiple features predict one outcome. Example, predict house price from size, location, and age. Polynomial regression. Still linear, but with curved relationships. Example, predict crop yield with temperature. Too hot or too cold is bad. Regularized regression prevents overfitting with many features. Ridge and lasso regression add penalties for complexity. How do you know if your linear regression is working well? Use these metrics. R-squared score. ranges from 0 to 1. Zero point 0.8 plus is great model. 0.5 to 0.8 is decent model. Below 0.5 is poor model. Mean absolute error, MAE, average prediction error. Lower is better measured in your target units. Root mean squared error, RMSE, penalizes large errors more. Also lower is better. The key? Always test on data your model hasn't seen before. Let's see a complete example with real evaluation. This gives us a complete picture of model performance in just a few lines. Here are the essential tips for success with linear regression. Before building, always visualize your data first. Check for linear relationships. Handle missing values and outliers. During building, scale your features if they have different units. Use cross-validation for robust evaluation. Start simple, then add complexity. After building, check residuals or prediction errors for patterns. Test assumptions like linearity, normality. Monitor performance over time. Pro tip: linear regression works best when your features are not highly correlated with each other. Avoid these common pitfalls. 1. Assuming linearity. Always plot your data first. 2. Ignoring outliers. They can completely change your line. 3. Using too many features. More isn't always better. 4. Not splitting data. Always test on unseen data. 5. Forgetting to scale. Features with different units need scaling. 6. Extrapolating too far. Don't predict beyond your data range. Remember, linear regression is powerful, but not magic. It needs the right conditions to work well. Ready to go deeper? Here's your learning path. Immediate next steps. Practice with real data sets, Kaggle, UCI ML repository. Learn about regularization, ridge, lasso. Explore polynomial features for curves. Advanced topics. Logistic regression for classification. Time series regression for forecasting. Bayesian linear regression for uncertainty. Tools to master. scikit-learn for implementation. Pandas for data manipulation. Matplotlib Seaborn for visualization. Remember, linear regression is your foundation. Master it first, then explore more complex algorithms. Let's wrap up. Linear regression is a simple but powerful algorithm for predicting numbers, based on finding the best straight line through your data. Fast, interpretable, and widely applicable. Your go-to baseline for regression problems. Key takeaway? Start with linear regression for any prediction problem. It's simple, fast, and often works surprisingly well. Your challenge? Find a dataset and build your first linear regression model this week. Share your results in the comments below. If this helped you, like this video. Subscribe for more ML content. Hit the bell for notifications. Share with someone learning data science. What's next? Vote in the comments. Should I cover logistic regression, decision trees, or neural networks next? Thanks for watching and keep learning.